Hi, welcome back everyone. This is Mohammed Inzamam. Let's continue our new topic now, that is inverse trigonometry. Every year you are going to get one or two questions guys from inverse trigonometry topic. So in this part we are going to discuss about what is the meaning of function, injective, surjective, bijective, domains and ranges. What are the domains and ranges for basic function? What are the domains and ranges for inverse function? Their derivations, their diagrams and everything we are going to see in this chapter. At last we are going to remember the formula, logical formula, and then we are going to solve the problem by logics only. Okay. First of all, let's try and understand about the first definition. What is the meaning of a function? Function is none other than a map guys. A map is said to be function. A map is said to be function if, condition is there guys, if each input has one output only. If each input has one output only, you need to focus guys. Okay, input is the x-axis guys, input is the x-axis now, and output is what? Y-axis. Output is your y-axis. Okay, let me draw here one value, one input I am taking over the x. This is an input value. How many output values I am going to have guys for this value of input? One value only. Similarly, one more input let's take over the x value. This is the x value guys, input, and what is the y value now? This is the y value, that is output. So for each input, how many outputs you need to require? You need to have only one output. Okay, that's also called as vertical line test guys. It is also called as which test now? Vertical line test. From this vertical line test we can understand whether it is a function or not a function. When you draw a vertical line, ఎప్పుడైనా మనం vertical line draw చేసేటప్పుడు ఆ curve అనేది, ఆ function curve అనేది, if it is going to intersect more than once, it is not a function. Only one time if it is going to intersect, it is called as function. I am drawing a vertical line, How many times it is going to intersect? One time. How many times it is going to intersect? One time. Similarly, let's draw here one more vertical line guys. Observe. I am drawing a vertical line. Now it is going to intersect how many times guys? Two times. So how many outputs you are going to get? Two outputs you are going to get guys. Observe here. I am drawing one line. This is one. This is one. Okay. This is one, and this is again what? One. Possibility is there that two inputs are going to give you what? One output. Your area of interest is how many outputs guys? One output only, because sin 0 is what guys? 0. Sin 180 is also what? 0. Yes or no? Sin pi 0, sin 2 pi 0, sin 3 pi 0, because it is a sine wave now. So many inputs can give you one output, that's okay. But one input should not give you more than one output guys. Here one input for one value of x, there are how many values of y? Two values of y guys. Understand you or not? So if you can write here y square is equals to some 4ax, y square is equals to some 4ax, x square is equals to some 4ay. So if 4a is a constant guys, y is equals to some root of x value, that is plus or minus, minus. So how many outputs you people are going to get? Two outputs. So which is a function and which is not a function guys? Yes, the first one is said to be a function. First one is said to be a function, whereas second one is not a function, because it is having how many output values? One output or more than one output guys? More than one output value. Okay. So here as per the Venn diagrams are considered, here you can write many to one. This is many to one, function is there guys, and this is 1 to 1. Observe, this is 1 to 1, this is many to 1. Output must be what guys? 1. Output must be what now? 1. This is not a function. Why? Because here we are having 1 to many. There are other definitions also to go for a function guys. For as far as our area of interest of inverse trigonometry is concerned, I am taking this as a definition. Okay. Chalo, pause the video and note it down. Let's continue the topic guys. We have completed what is the basic definition of function. Now let's talk about injective and as well as surjective. Sir, what is the meaning of injective now? First of all, let's draw a basic diagram to understand it well. I am drawing two diagrams. Let's say this is one and let's say this is another diagram. Okay. Meaning of injective is no two inputs have same output. No two inputs have same output. Observe, input is what? X value. Output is what? Y value. Input is x, output is y. Okay, I am drawing one input value, any value of x, guys. There must be only how many outputs? One output only. Anywhere on the x, if you draw a vertical line, you must be having only one. Understanding or not, guys? Similar to that of the first one, function definition. Observe here, no two inputs. Observe this one. No two inputs. These are two inputs. Must have same output. Must have same output. So now, for this value of x1, for this value of x2, guys, you are having the same value of y or not? Yes, you are having the same value of y. That is for y1, y2, both are what? Same. Two inputs are having same. That means it is not a injective function. This is an injective function. Okay, let me write it here by means of the Venn diagram. Observe, guys, over the Venn diagram also you can understand it very clearly. If I am putting one input, there is one output. There is one input, there is a one output only. Okay, over this diagram, observe, one value is going to give you what? Same value here. X1 is going to give you one value. X2 is also giving you what? Same value. X1 is also giving you same value. This is many to one. This is function is existing, but it is not a injective, not an injective function, because two inputs are having same value. Okay, here you can observe it is injective now. One input, one out, one input, one output. So yes, it is an injective. Another name for injective for easy understanding is one-one function or one-to-one function. Here we are having what? Many to one. So many to one cannot be one-one. So easily you can remember now, one-one, one input, one output. No two inputs must have same output only. Okay, try and understand. Now let's move on with another one, that is surjective, guys. Let's see what is the meaning of surjective also. Surjective is called as onto function. Okay, surjective is called as which function? Onto function. If I draw Venn diagram, you can understand very easily, guys. Two Venn diagrams I am going to draw. Observe here. Let's say this is capital B, this is capital A, this is capital E, capital B. Elements of B is small b, elements of A is what? Small a. Okay. Observe here. Here we are having three values, here we are having three values. Okay. This is many to one, this is many to one, this is many to one. Observe. Here one atom, here one element of B has been left out or not, guys? Here one element of B has been what? Left out. Here one, it is not mapped to element of what? A. It is not mapped. Okay, observe that. So it is not going to be what? Surjective. Similarly, observe the next diagram, guys. You can understand it very well. This is 1, 2, 3. Again 1, 2, 3. Three elements are there. 1. Again I am doing 1. Again I am doing what? 1. Okay. Yes. Observe here. So now all the elements have been what? Mapped. That means you need to write in this manner that B, for all B belongs to capital B. B, that means small b. This is B. Small b are the what? Elements, guys. Okay, small b are the elements. B belongs to capital B. There exists an element A which belongs to capital A. Element A which belongs to capital A. For all, this is f of A is equals to what? B. Matter is surjective definition. Let me write here, guys, so that you can understand clearly. All the elements of B must have mapping with what? Elements in A. Elements in what? A. All elements, that is small b, belongs to capital B, must have mapping, or mapped with A elements belongs to capital A. This is you need to remember, guys. Here one element is not even mapped with now. So this is not a surjective. This is not a surjective. Here all the elements have been mapped. So yes, it is surjective. Yes, it is a surjective. Observe last one now. What is the meaning of bijective, guys? Meaning of bijective. Bi means what? Two. Bi means what? Two. If a function is going to what, guys? Obeys both injective and as well as surjective, that function is called as what? Bijective. That function is called as what? Bijective. That means it should obey both one-one condition and as well as onto condition also it need to satisfy. That we are going to see in the next slide. Chalo, pause the video and note it down. Let's continue the topic, guys. Now we need to see about a bijective function. What is the meaning of bijective? By itself indicates it is combination of some two conditions. That means it should satisfy, a function should satisfy, both, what are that both conditions, guys? Injective, that is 1 condition, and second one, that is surjective. What is the meaning of surjective, guys? Onto condition. That means all the elements of B must be mapped with elements in A. If you want to understand, let's try and understand with the diagram, guys. Suppose these are some four elements given here. First of all, let's draw the 1 function. What is the meaning of 1 function, guys? 1 input, 1 output, 1 input, 1 output, 1 input, 1 output. So this is 1. What is the meaning of onto, guys? Onto means all the elements of B, that is codomain, must be mapped. All the elements have been mapped or not? Yes. So yes, it is 1 1 and as well as onto function. If it satisfies both these conditions, guys, it is said to be what? It is said to be bijective. Bijective. If we want to see the graph, guys, the graph will be looking like in this manner now. Let me draw a line which is going to pass through the origin. Okay, this is the line which is passing to the origin. Now observe, guys, here we are having 1 input, 1 output, 1 input, 1 output, 1 input, 1 output, and all the elements of X are having certain value over the Y or not? Yes, they are having. So yes, this is an example of what now? This is the example of bijective function. This is the example of what, guys? A bijective function. Chalo, pause the video and note it down. So now let's continue our topic and let's move to the domains and as well as ranges of basic function and inverse function. Okay, first of all, let's talk about some important points, guys. The first important point is a function is invertible. A function is invertible if it satisfies injective and as well as surjective condition. In short, it must be what, guys? Bijective. It must be what? Bijective. Let's start the first trigonometric function, that is a sine function. The first trigonometric function, that is what? A sine function, guys. Sine x, sine theta, something. It's up to you. Try and understand carefully, guys. What is the sine function now? This is the sine function now. From where the sine function is going to be started over the x? Minus infinity. Where it is going to end, guys? Plus infinity. What is the highest value over the y? Plus 1. What is the lowest value over the y? Minus 1. Okay. The x values are called as what? Domains. This is the sine function, guys. For the sine function, I am writing what? Domain. And as well as what? Range. Domain and as well as range. There are 3 steps you need to remember, guys. This is the first step. And the sine is what? A non-invertible function. Why it is non-invertible, guys? I will show you. Let me write first of all the x values. What are the x values? Minus infinity to plus infinity, denoted with which bracket? Open bracket, because infinity is not a number. This bracket indicates you should not count the minus infinity in infinity. All the numbers which lies in between minus infinity to infinity you are going to count. Simply they are none other than all real numbers. Real numbers ni etla denote chestam manam? Capital R tho denote cheyali. Okay. Next one, range. Range ante y values. From where to where they are varying, guys? They are varying in between minus 1 to plus 1 included bracket, because minus 1 is there on the graph, plus 1 is there on the graph. So minus 1 plus 1 kuda manam em cheyali? Include chesukovali. So domain ochindi manaku ippudu range ochindi. Domain and as well as range. But this is for sine which function, guys? Invertible sine na non-invertible sine na? Non-invertible sine. Sir, why are you writing it is non-invertible sine? Cheptanu vinandi. Observe. Sine 0 value enti cheppandi? 0. Sine 180 value? 0. Sine 2 pi value? 0. So if sine 0 value is 0, this is sine 0, 0, sine 180, 0, sine 2 pi, 0. So So this is a which function, 1 to 1 function or many to 1 function? Many to 1 function. If it is many to 1 means it does not satisfy which condition? Injective, not an injective. If it is not an injective guys, it is non-invertible function. అవునా కదా? చలో ఇప్పుడు ఫోకస్ చేయండి. నోట్ సెకండ్ పాయింట్. నోట్ ఒక నాన్ ఇన్వర్టబుల్ని ఇన్వర్టబుల్ ఫంక్షన్లో ఎట్లా కన్వర్ట్ చేసుకోవాలి? నాన్ ఇన్వర్టబుల్ ఫంక్షన్ని ఇన్వర్టబుల్ ఫంక్షన్లో ఎట్లా కన్వర్ట్ చేసుకోవాలి? You need to restrict the domain guys. What you need to do? Restrict the domain. Restrict the x values also you can tell. Restrict the x values. ఎందుకు సార్? Why we need to restrict the x values? ఈ x values ని restrict చేస్తే ఏమవుతుంది చూద్దాం. చూడండి ఈ వాల్యూ అనేది రిపీట్ అవుతుంది. పీరియాడిక్ ఫంక్షన్ కదా, పీరియాడిక్ ఫంక్షన్. ఇప్పుడు చూడండి sin 0 0, ఇది మళ్ళీ ఇక్కడ రిటర్న్ వచ్చింది కాబట్టి వాల్యూ రిపీట్ అయింది. అంటే మనం ఏం చేయాలి? ఈ ఎక్స్ట్రా వాల్యూస్ని ఎలిమినేట్ చేసుకోవాలి. ఇప్పుడు చూడండి ఇన్వర్టబుల్ సైన్కి ఫంక్షన్ డయాగ్రామ్ డ్రా చేస్తున్నా. దిస్ ఇస్ ద డయాగ్రామ్ దట్ యూ నీడ్ టు రిమెంబర్ నౌ గైస్. This is the standard diagram. Observe. Now it is similar to that of that vertical line which I have just drawn in the previous slide guys. Just drawn. Okay. ఇప్పుడు చూడండి వాల్యూస్ ఏమైనా రిపీట్ అవుతున్నాయి ఇక్కడ? నో. Yes or no guys? Non repetitive diagram it is. From where it is starting? It is starting from minus pi by 2. Where it is going to end guys? Plus pi by 2. X values ni మాత్రమే చేంజ్ చేసినాం. Y values అట్లానే ఉంటాయి. Y values are what? Plus 1. Y value is what guys? Minus 1. Okay na? Now this diagram is called as what? Invertible sine diagram. ఈ diagram ని మనం ఏమనాలి? Invertible sine diagram అనాలి. ఎందుకంటే ఇది it is not going to repeat the values guys. It is not going to be many to 1. It is going to be which function now? 1 to 1 function only. Diagram చూడండి ఎట్లా ఉంటుంది. How the diagram is going to be guys? For every value of x there is only one value of y. Now this is which function guys? 1 to 1 and onto function. ఆంటో గురించి మనకు ఎక్కువ టెన్షన్ పడాల్సిన అవసరం లేదు. ఎందుకు? బికాజ్ ఇట్ ఈస్ గ్రాఫ్ గైస్. గ్రాఫ్ మీన్స్ వాట్? ఫర్ ఎవ్రీ వాల్యూ ఆఫ్ ఎక్స్ దే ఎగ్జిస్ట్ వన్ వాల్యూ ఆఫ్ వై. అంటే మీరు చెక్ చేయాల్సింది ఒకటే. వాట్ ఈస్ దట్ గైస్? 1 1 ఫంక్షన్ ఉందా లేదా టెస్ట్ చేసుకోవాలి. ఇది 1 1 మెనీ టు 1 మెనీ టు 1 ఫంక్షన్. దిస్ ఈజ్ అ మెనీ టు 1. చూసుకోండి ఒకసారి. దిస్ ఈస్ మెనీ టు 1, మెనీ టు 1. దీస్ ఆర్ మెనీ అండ్ యూ ఆర్ గోయింగ్ టు హ్యావ్ ఓన్లీ 1 వాల్యూ. ఓకే, మెనీ టు 1 ఫంక్షన్ ఇది. ఇక్కడ చూడండి దిస్ ఇస్ 1 to 1 ఫంక్షన్. చలో ఇప్పుడు ఏం చేద్దామంటే ఇన్వర్టిబుల్ డొమైన్ అండ్ రేంజెస్ రాద్దాం. డొమైన్ అండ్ రేంజెస్ రాసే ముందు ఒక నోట్ పాయింట్, ఇంకో నోట్ పాయింట్ ఉంది, ఇది కూడా గుర్తుపెట్టుకోవాలి. ఓకేనా? వాట్ ఈస్ దట్ నోట్ పాయింట్? ఇఫ్ దే ఆర్ టూ ఎఫ్ మ్యాప్స్, దిస్ ఇస్ ఎఫ్ మ్యాప్స్ x to y, f maps x to y is invertible. Invertible ఉంటే there exists another function g maps y to x, g maps y to x. That means x values y values x తో మనం ఇంటర్చేంజ్ చేస్తే g is inverse of f, g is inverse of f. ఇది గుర్తుపెట్టుకోవాలి. వాల్యూస్ ఈజీగా అర్థమవుతుంది. చూడండి ఇప్పుడు సైన్ ఇన్వర్టబుల్ రాస్తున్నా. ఫస్ట్ ఇన్వర్టబుల్ సైన్ ఇది. ఫస్ట్ వన్ ఏం రాయాలి? డొమైన్ రాయాలి. ఫస్ట్ వన్ ఏం రాయాలి? డొమైన్. సెకండ్ వన్ ఏం రాయాలి చెప్పండి? రేంజ్. సెకండ్ వన్ ఏమొచ్చింది? రేంజ్. ఇది ఇన్వర్టబుల్. ఓకే, డొమైన్ చెప్పండి, రేంజ్ చెప్పండి. డొమైన్ అంటే ఎక్స్ వాల్యూ, రేంజ్ అంటే వై వాల్యూ. రేంజ్ అంటే వై వాల్యూ. చెప్పండి ఇప్పుడు వాట్ ఈస్ ద డొమైన్ గైస్? ఎక్స్ వాల్యూస్ ఏమున్నాయి చెప్పండి? -π/2 to π/2. -π/2 to π/2 కౌంట్ చేసుకోవాలి. -π/2 to π/2 కౌంట్ చేయాలి. కౌంట్ చేయాలంటే మీనింగ్ ఏముంది? క్లోజ్ బ్రాకెట్తో రాయాలి. ఎందుకంటే π/2 ఇస్ దేర్ ఆన్ ద కర్వ్. π/2 ఇస్ దేర్ ఆన్ ద కర్వ్, అందుకే క్లోజ్ బ్రాకెట్తో రాయాలి. ఓకేనా? వై వాల్యూస్ దేనికి మధ్యలో వేరీ అవుతున్నాయి చెప్పండి? వై వాల్యూస్ ఆర్ వేరింగ్ ఇన్ బిట్వీన్ వాట్? -1 to +1. చలో బేసిక్ ఫంక్షన్, డొమైన్స్, రేంజెస్, బేసిక్ ఫంక్షన్ గురించి తెలిసింది. ఇప్పుడు మనకు కావాల్సింది బేసిక్ నా ఇన్వర్స్ నా? ఇన్వర్స్ ట్రిగ్నోమెట్రీ కదా, ఇన్వర్స్ ఫంక్షన్స్ కావాలి కదా, అవునా కదా? అంటే సైన్ ఇన్వర్స్. ఇప్పుడు అర్థమవుతుంది చూడండి, ఈ స్టేట్మెంట్కి మీనింగ్ అర్థమవుతుంది చూడండి. జీ ఈజ్ ఇన్వర్స్ ఆఫ్ ఎఫ్. ఎఫ్ మ్యాప్స్ x to y, g మ్యాప్స్ y to x. అంటే x ప్లేస్లో y రాయాలి, y ప్లేస్లో x రాయాలి. x ప్లేస్లో y రాయాలి, y ప్లేస్లో x రాయాలి. వాట్ ఇస్ ద సైన్ ఇన్వర్స్ డొమైన్? -1 to 1. సైన్ ఇన్వర్స్కి డొమైన్ ఏమవుతుందో చెప్పండి? -1 to 1. సైన్ ఇన్వర్స్కి రేంజ్ ఏమవుతుందో చెప్పండి? -π/2 to π/2. ఈ విధంగా గుర్తుపెట్టుకోవాలి. దిస్ ఇస్ ఆల్ అబౌట్ ద బేసిక్ ఫంక్షన్స్ గైస్. బేసిక్ ఫంక్షన్స్, ఇన్వర్స్ ఫంక్షన్, నాన్ ఇన్వర్టబుల్ అండ్ ఇన్వర్టబుల్ ఫంక్షన్. మళ్ళీ ఒక నాన్ ఇన్వర్టబుల్ని ఇన్వర్టబుల్లో ఎట్లా కన్వర్ట్ చేసుకోవాలి కూడా మనం చూసుకున్నాం. ఓకేనా? చలో పాజ్ ద వీడియో అండ్ నోట్ ఇట్ డౌన్ గైస్.